Sir, resistivity, if I'm not wrong, the unit is ohm meter, no, sir, because R is equal to rho L by A.
Yeah.
So A comes to numerator, so it will be ohm meter, sir.
Yeah. Pardon?
No, the unit for resistivity, sir.
Ah.
If I'm not wrong, will be ohm meter, sir, not ohms per meter, sir.
Yeah. Yeah. That's okay. Okay. Yeah.
Okay.
Okay. Exactly. So ohm meter.
Okay, sir.
It should be ohm meter only because unit if you apply automatically will be ohm meter per this one.
Yes, sir.
That's what it is. So this value is fixed for a given
Understood.
material. Okay.
Understood.
Now I
Understood.
have a wire having a length L and it cross section area H into W, that is area. I say capital A. Then I can find the resistance of this wire from this end, correct, to this end. If I connect to a ohm meter, correct, I connect to a ohm meter. What will be resistance? I can calculate using this formula. This is the principle behind the strain gauge sensor. Very simple, correct? If a given wire, if it is made of certain material, copper or aluminum, the resistivity is fixed. Okay, that's not going to change. Then what are other things are? Length is there, area is there. Depending
Sir,
on
can you just, sorry for interrupting, sir.
yes,
Can you just help us summarize what resistivity actually means? It's basically a property of the wire, right?
it is property of the wire. The resistivity definition very simple. Resistivity is the property of the wire, which opposes current flow.
Okay.
Current flow in the wire, which opposes current flow. That means more resistance, less current can go. Lesser the, now we know that resistance R equal to 0. Any idea which material has this resistivity R equal to 0? Anybody?
Superconductor.
Fantastic. That is called superconductor. Right? Superconductor is nothing but when material is subjected to 0 degree Kelvin. That is called absolute temperature. Absolute zero. If any material in periodic table, if the material is subjected to 0 degree centigrade, Kelvin, we call absolute zero, the resistivity of the material becomes, that material becomes 0. Correct? That means if I take a wire, okay, that will come back. So that is one thing. But on the room temperature, other than 0 degree Kelvin, the resistivity rho is varying. Correct? Resistivity for the material is fixed. Resistivity is fixed, but the resistance changes due to this parameter. This is fixed. This is changing. If I change, for instance, this is 10 centimeter. This is say 0.1 cm square area. A equal to this much, L equal to this much, rho equal to I say 0.00015 for the wire. Then I can say R equal to, I can substitute. If I substitute this, I know the resistance of the 10 centimeter wire, which is having cross section of 0.1 cm square with the resistivity of this one. Okay, that means now if I apply a force, if it now this is how it works. This is called as strain gauge. The wire is called as a conducting wire is called as strain gauges. Only thing that is not made of copper, not made of aluminum, not made of this one. They made some composition of conducting copper plus some other, they don't tell, nickel plus something under constantine, all the things, some percentage they add. They make a material alloy, then they make it as a wire. That alloy, Cu alloy, exactly they don't tell because that is secret, trade secret. Correct? Maybe generally you can find out this one. Then using that they draw a wire. Generally we say the wire can be in cylindrical shape, correct? Solid cylinder. That's how most of the wire will see that cross section area of the circle. It has a length L. For understanding purpose, we said that this square. The only thing is to calculate. It can be cross. Any type of wire has a cross-sectional area with a length. This is length and this has a and it has resistivity. Then you can apply this formula. Okay. Now, in this one, what I did is, correct, to one end of the wire, this end, I can say that I will get different color, I will show it. This end is fixed. Correct? It cannot move. This end, I am applying a force. Correct? What force? Tensile force I am applying. If you apply tensile force, what will happen? The wire will get elongated. When I apply tensile force, the wire length has increased L plus delta L. Original length was L. Additionally, because the original length, this is delta L. This was the original L. So total length is delta L. Meanwhile, what will happen? If wire is stretched, pushed because of tensile force, length automatically the cross-sectional area, the W will reduce, correct? To W minus delta W. This much it will reduce. Similarly, height also will reduce. Sorry, this also will minus by typing this mistake, correct? So the H also will reduce. So the new is because, for example, this I say 1 mm. How much we are talking? Something 0.1, correct? So 0.1 cm and this also 0.1 cm. Now, if I stretch, it becomes 0.09 cm and this also become 0.9 cm. So we multiply, the cross-sectional area reduces, correct? A reduces, the L increases. L increases, A reduces. What will happen to resistance? Automatically increase, correct? The denominator increases, numerator decreases. This is going to be a constant. So the resistance increases. So I applied a force, correct? One side fixed, other side I'm just pushing. So wire is get stretched. So the delta L and the change in delta L and delta W and delta this one, they are going to contribute in change in resistance, correct? How much delta L increases proportional to force apply, correct? So that means if I apply force, there's a stress. Because of that, there's a elongation length, also reduction in the cross-section area. This we call as strain, correct? Strain is nothing, change in dimension. The original wire dimension has changed. Length increased by delta L. The cross-sectional area reduced by, I say A minus delta A is the new A, correct? So it is reduced. So the dimension, that's why we call this as strain gauge, correct? This is gauge means measuring device, already we know, correct? What it is measuring? Amount of the force applied. Using, if I am able to measure the change in resistance, correct? So that means my R, new R will become, I say R2. This one I call R1. This I call R2 of the new elongate wire. R2 equal to R1 plus delta R. Okay, the delta R is due to the delta L and delta W change, correct? Area changing, correct? So that means if I'm able to measure this one, because of this, there's a change in distance. If I measure the change in distance, what I do? Now I applied force F of T, 1 Newton, correct? I applied 1 Newton force. Originally the resistance R. For example, this R was 100 ohms. For example, I calculated for this material for given length of 100 ohms. Now I applied a force of 1 Newton force, correct? When I applied 1 Newton force, the resistance increased 101 ohm, correct? I applied 2 Newton. What will happen? The delta L will become, for example, this was 1 mm. If I apply more force, it becomes 2 mm, correct? Proportional delta W will decrease, A will decrease, correct? A will decrease to new delta A, correct? That will be smaller. So automatically, due to that, resistance changes. So my resistance become 102, 3 Newton, 103, correct? I apply 10 Newton, it become 110. So that means I can know that my delta R changes from 1 to 10 ohms, from original ohm 100 ohms, correct? So this is proportional to force applied, 1 to 10 Newton, correct? Now the wire, the copper wire is my strain gauge. This wire made of some material, correct? What I did, by applying different force, I calibrated the wire. Only thing is, if I release the force, this would come to original length of 100, 10 mm, 10 centimeter, whatever it may be. It has to return back to original, correct? You should not stretch beyond the elastic limit. Then it will not come back. So strain gauge, the force applied such that the change in length and the stress strain coefficient that it doesn't go beyond the elastic limit, so that it come back, correct? Plastic deformation happen, it never comes. It should be within the elastic limit. Plastic deformation happen, it won't come. So that means you should know how much force you can apply for this wire having some length and cross-sectional material. And so once you can apply different forces, now you got a graph. What you will get? You will get a graph, correct? You will get a graph something like this. This is change in R, correct? 0, 1, 2, 3, like this. This is 10. Okay. Similarly, we are getting the this one, strain. Correct? Strain is measured in terms of the length change. Okay, how much displacement happened. Correct? The strain is proportional to force. Please note that strain only we are measuring, that means change in length and divided by change in area. Correct? But that is directly proportional to force. Now, if I apply a force, then the change resistance changes. So I can say like this: the x-axis, the force, 0 to 10 Newton. Y-axis is nothing but my change in resistance R. So apply different value, I'll connect, we'll get a line. This line is nothing but calibration graph. Okay, now I know that if I apply 10 Newton, my change in resistance is 10 ohms. Okay, how will you measure this change in resistance? You can use a ohm meter. I can connect a ohm meter, and using which I can measure the change in resistance. Otherwise, what I can do is I can use what you call a Wheatstone bridge. I can use Wheatstone bridge to measure the change in resistance of the strain gauge. Okay, so now once this is done, now what I'm doing, I apply an unknown force, because this is the calibration I have, 0 to 10 Newton. It says 0 to 10 ohms, it changes. Now I'm taking this wire and I wanted to measure force in some other device. The wire can use a sensor. What I do, I attach this to a device which is pulling, generating a force this direction. I attach this wire, this end is fixed. Now I don't know the force, how much the device is creating. I don't know, correct? But I'm measuring this ohm meter, it shows the 7 ohms. You apply some force, unknown force, to this wire which is already calibrated, it says 7 ohms. From this graph, automatically you can say that this 7 Newton force, correct? You can always say that this 7 Newton. You apply some other force, the change in this delta R equal to 3. Then I know that from the graph I can say that the applied force is 3 Newton. So now that I can use this wire to measure the unknown force. But first thing is I have to calibrate. That is done by the strain gauge manufacturer. This is what the basic principle behind my strain gauge. Okay, so
Sir, I have a question.
yes, please.
Device, then it will come calibrated in some conditions, right?
Yeah.
So now let us say
He will say what is maximum force you can apply, what will maximum resistance it will change. That data will be in data sheet, you will say.
Okay. So, but can it be a case where the operating conditions will make the wire itself to expand or contract, and it will remain in that state? So the length has changed from the factory setting. So the data we are getting might be wrong or something. Can such a case occur, sir?
No. Which one? The length change permanently remains as it is.
Yes, like I mean, like the weather conditions in which they're using the device is changing, because of which the wire itself is contracting or expanding.
Okay.
The default resistance, what we are measuring, is itself changing.
No. That is why they use a special material.
Okay.
Which will have very small thermal expansion. Very small thermal expansion. That's why they don't tell the secret. I told you copper wire for understanding purpose. This strain gauge is made by few companies around the world. They are leaders. One company called HBM, Hartinger Baldwin Mesh Technique. It is a German company. I am using the strain gauge bought from this company for last 40 years. In IIT, most of the research scholar, professor, everybody is using HPM strain gauges. They are very popular. One of the leading company in the world. One of the company. I'm not saying only one company. One of the company. They are making this kind of strain gauges. I have strain gauges. I bought it from HBM. I'm using for other purpose. Of course, there are other companies, Japanese company, all those things. India also some company make, but they are not very stable. Correct? They don't use right material. HBM is a trade secret. What they generally know that it is a copper composition or copper alloy. How much copper? What is the other material they are not telling. It won't expand thermal expansion. Even if temperature change 30 to 50 degree, the length will not change beyond some few micrometer, less than a micrometer.
So tolerance is really low.
Very, very low.
Just
It won't expand thermal, we call thermal expansion.
just a thought, sir. And
Yes, please.
I understand that like it's a trade secret, but if we have the material, I think like through the lab we will be able to find the composition of the material.
You can find. It's not that impossible. I am not saying. See the material allied is not only composition, the heat treatment decides.
Okay, agree. Sir.
Right? That is a process. Nobody, that Damascus steel. How many of you know Damascus steel?
We know, sir. Like it's by continuously folding sheets of steel, right? Like continuously folding.
They fold, take a sheet, fold it.
Yes.
2 times. They make even 10,000 layers. Same thing, folding, pressing, folding, again pressing. They are multi-layer, correct? That is a special steel where the carbon contents outside will be very high, inner it will be low. They control the carbon content while making the steel, while folding and heating, correct? They put in the furnace.
Some pattern on it.
Pardon?
It will have some pattern etched onto it.
Yeah. You know where they made the first Damascus steel?
India, I heard, but it sounds like Syria.
What is the Damascus? What do you mean by Damascus?
Damascus is a city.
Where? It is Syria capital. Syria capital. Yes. European came to know about the steel around 2000 years or 1500 years before from the Damascus. Damascus, the traders were selling the steel, but originally it was made in India, South India, in Tamil Nadu and in Sri Lanka, 2000 years before. This is a special steel. Using that, they make a sword. Normal sword, steel, just stainless steel can break. This won't break. Even if you bend a little bit, it can stay in this stand. And the sharpness, it won't go. This was invented in South India and Sri Lanka, in Tamil Nadu. And because we know Tamil Nadu, Tamilians were there in Sri Lanka also that time. Correct? So from there, the Arab people came around 1800, 2000 years before, trading from Arabia, Saudi Arabia area to Tamil Nadu to the Sangam period. That time they took this one and they went up to Syria. From Syria, the European country, they did not have the technology. They were using only pig iron, all this iron, steel, all this thing, quality was not there. From Damascus, they buy the raw material, billets, which was made in South India. It went to Damascus city. That traders will sell it to Europeans. That's why they call Damascus steel, Damascus steel. Correct? Similar kind of steel is available in Japan. They make a sword. Very famous sword. Anybody know the name?
Sword of Damascus.
Huh?
Sword of Damascus.
No. Katana.
Sir, it is used in many...
Immediately don't say Gus and it's a Damascus sword. No. It is called katana sword. Each sword nowadays, katana sword, if you want to buy it now, it costs $20,000 to $50,000. Making is so difficult. In Japan, they were doing samurais. You would have heard about samurai. Samurai must have a katana. If you don't have a samurai, the katana is not a samurai. One of the equivalent, same quality, like a Damascus steel. Okay, that is different. Okay, fine. We'll go ahead with our class. Okay, so now that we know what is the strain gauge, how it works, basically it resistance changes. That's why I said strain gauge is called change in resistance type sensor used for measuring force, torque, or pressure. When we see our force torque sensor, we'll see that how this can be used. Okay, so basic principle. So now how the sensor works, a little derivation is there. We know that strain gauge is a wire. Wire means as resistance R is rho L by A. This is the first equation. And by taking the log is nothing but natural log. Ln means natural log. Natural log of this equation, R equal to rho L by A, it will become log R. Natural log R equal to log rho plus log length minus log n because it's in denominator. This is my second equation. Now, this equation is different. Please note, take this derivation. In exam, you may expect questions. Derive that the strain gauge, the change in resistance is due to the length change and also the this one cross-section area change. Prove through the derivation. Okay. So now we got the log then you differentiate this equation 2. If you do that, it become delta dr by r equal to d rho by rho plus dl by l minus dA by A. Okay, the third equation. And we know that the area of this wire, which wire? This square type wire is nothing but omega, the W into H, width into height. A equal to V at this one. So if you substitute this in this equation, correct, I can say dA in this part, dA by dA equal to W into DH plus H into dW divided by W into H, can be written as DH by H divided by dW by this one. That is change in height divided by original height of the wire. We are talking about this one. And the change in the width divided by original width equal to dA, change in area divided by A. dA by A equal to DH by H plus this one. This is fifth equation. Okay. Now, using Poisson's ratio definition, Poisson's ratio is a scientist who found the Poisson's ratio, which we are going to talk about it. The Poisson's ratio definition, my dA by A can be written as a minus nu. This is reference of nu. This is the Greek symbol name called nu. That's what they say as a nu. Nu into dL by A. And dW by W equal to, that is change in width divided by original width, can be written as minus by the nu into dL by L. Now, we can write this dA by A equal to minus 2 into nu into dL by L. Can be written as minus 2, nu is there, delta L by L is nothing but strain. We know change in length divided by original length is called a strain, which is represented as eta. Okay. So now using this is equation number 7. Using this value, correct, dA equal to minus 2 nu into I think the epsilon. It is called as epsilon. Right? We know that we call epsilon. Okay. So epsilon, you able to do this one. In the equation 3, we can obtain dr by R, change in rest by R, okay, into nu equal to 1 plus 2 into this one is rho divided by rho. This is nothing but resistivity, correct? So now by dividing this equation 8 by this strain, correct, epsilon, I can say that dr by R. Here you have the multiplication. Please see that there's already epsilon is there. So divided by epsilon, you can do that 1 plus 2 nu into d rho by d, the rho divided by epsilon, which is called as the strain. I get this equation 9. And before I'm going to further, because generally nu is called Poisson ratio for strain gauge material, generally varies something from 0 to 0.5. Most of the time it is called metal strain gauges. Short form SG, metal strain gauge, nu equal to Poisson ratio equal to 0.3. Generally, most of these strain gauge material, I told you, trade secret, they don't tell, whether HBM or Japanese, any company. If you ask the Poisson ratio of this one, they say it is around 0.3, 0.35 something. But it can vary anywhere between 0 to 0.5. 0 generally no, but at least greater than 0. Okay. Another thing what you have to know is gauge factor, they call it G. Take this. G equal to delta R by R divided by delta L by L. Delta is change in resistance of wire from the original resistance. I said strain gauge, the wire was 100 ohms. I applied a force, it became 101. What is delta R? 1 ohm. 1 ohm divided by 100. Here I said delta L. Original length was, for example, 100 mm, and delta L change in length may be, for example, 5 mm. 5D. So this is nothing but your strain. Correct? Delta R by R divided by delta L by L is called as gauge factor. Correct? Gauge factor is one of the important parameter for the strain gauge. While you are, suppose you want to buy a strain gauge, you need to look for this information. Higher the gauge factor, it is better. We'll say why it is in next slide. Okay. So now that we have the derivation, dr by R divided by epsilon equal to 1 plus 2 into nu into d rho divided by epsilon. This is my equation number 9. Okay.
So,
Now, Yeah.
Sorry to interrupt, sir. On the first line also dA by dA is there. Second line is also dA by A. But there is a difference. Epsilon is there, but in the below 2 epsilon is there, sir.
His second line -2 epsilon. Okay, this one you are talking?
Yes, yeah, the first, yeah, correct. And in the first line, dA by A is equal to minus epsilon, dL by L is there.
So I think it is dH by H plus dW
Yeah,
by
dH
dP.
by
So
H
it
by
became, yeah.
Here.
First one should have been dH, right, sir? First
The
one.
first one might be dH, sir.
Yeah.
Here.
The second is, yeah, that should have been dH by H.
Yeah. Okay.
Because
Yeah,
two times if you have negative only, it will become -2.
No, you're correct. Okay, because while writing, I would have made mistake because I wanted to write. Okay, I will cross check and tell. Thank you.
Okay,
No issue. While writing, because very important. Correct. I am very happy that you are keenly looking at derivation. That is most important thing for a student. Fantastic. Correct. So if you are trying to look into that and see any error, I can, because it can get typo error. Why are you doing? Okay. So now we know that we got this equation, correct? By dividing this, we got this equation, and this equation you can see that this part is called as piezo resistive effect, because there you can see that in this equation one is a constant, 2 into nu is a Poisson's ratio, correct? Poisson's ratio. Another third part is the rho divided by R. This is called a piezo resistive effect of the given material or the strain gauge material. Okay, what it says is, as you apply more force, more strain is applied, there's a change in resistivity also. That is called a piezo resistive effect in strain gauge. Now, this also contributes to change in resistance. Please see that each and every component, change in length and correct change in area, and also change in the resistivity of the material when you apply when the strain gauge undergoes a strain. That is when you apply a stress. Stress is applied when you apply a force or a torque or a pressure. The strain gauge undergoes a stress. Due to stress, there's a strain is there. If strain is there, it has an effect on the resistivity of the material also. That is called a piezo resistive effect. This equation, what this was, the final equation was this. There are change in the resistivity of the wire itself when you apply a strain. Correct? This is how the combinedly the strain gauge resistance is changing. Okay. So this is to understand that if you apply a force or a pressure, the strain is there. The strain is one is lengthwise and also cross-sectional area. When these two things are changing, his resistivity also changes. That is affected by amount of the strain. Amount of strain is proportional to amount of force applied. So that means the change in resistance is affected by three components: area change, length change, and the resistivity change. That's what I wanted to do through this. Any questions? Okay. Now that we understand what a strain gauge, how a strain gauge will look. This is a picture of the strain gauge. I told you HBM company. I took it into website. So the strain gauge consists of just nothing but a wire, correct? But the only thing, it is a special wire. That wire is taken and put bonded, because this is a photograph of an actual strain gauge by HBM. You can see yellow color, this one. This is called a base. Already I think I have written. Yeah, non-conducting base material. Yellow color is a non-conducting special polystyrene, something like that. It won't expand thermally. Again, strain gauge, not only this one, strain gauge wire you cannot use directly on this one. So it is bonded on a non-conducting base material whose thermal expansion also very low. Correct? It should not. Then the strain gauge wire, which is shown in black here, is bonded. You can see that this is the wire which I am retracing on it. Please see that take a long wire. It is wound through a serpentine form. Correct? Like a snake. Correct? So serpentine form increase. What is this? I can, for a given small area, correct? This length, this may be 8 mm. This may be 10 mm. Most of the time, it can be still smaller also. Most of the time, the base size is only this, on which you can see the wire is bonded. The black color wire is this, nothing but that is the strain gauge wire that is bonded on this one. Then this is the connection through which you can take the wire. You can say electrical wire output, base non-conducting material on which the strain gauge wire is bonded using a special this one. So now the whole thing is called a strain gauge. Okay. Now, if I take this strain gauge, for example, I have a cantilever. Think like this. This is my cantilever, a rectangle cantilever. It is fixed on a wall. Right? And I am applying a force on the cantilever. A force is applied in one end, other end is fixed on the wall. I want to find out what is this force. I want to find out. What I can do is take the strain gauge and bond it here. Something like this. The whole strain gauge will be again using a special bonding. I bond it, take the wire out. Okay. Now now you apply a force, what will happen? The cantilever is going to bend due to the force. So slightly it may bend like this. Correct? It bends. So what will happen? In the top side, it is expansion, correct? It is expansion. Top surface is expansion. Bottom surface is cantilever compression. So that means this length reduces L minus delta L. This is L plus delta L. So I have bonded my strain gauge on the top side. So this strain gauge also will be going under same expansion. Whatever the expansion top side is happening in the cantilever, because the strain gauge is bonded using a special material, again special glue. You cannot take Loctite glue or your gum, all those things. So the strain gauge supply, HBM supplies special this one, so that the strain gauge is bonded. So if the top surface elongates, the strain gauge also will be stretched. Correct? It will be stretched. Otherwise, if I put the strain gauge at the bottom side of the cantilever, correct? Paste it using a special bonding, then there will be a compression. The bottom side is getting compressed, the length reduces, the strain gauge length also reduces. Original length is this, correct? This is my original length of strain gauge. I said that 10 mm. Now, if it is on top side, it may become 10.1 mm. If I apply, for example, 1 Newton force. If I apply 2 Newton force, it may become 10.2 mm. Correct? If I apply 3 Newton, 10.3. So that means the length increases, because the cantilever is similar. Now, due to that, already we know if length increases, automatically the cross-sectional area of this wire will reduce. So automatically delta R will happen. That means delta R will happen. Delta R may be, for example, 1 ohm. This is 2 ohm, 3 ohm. Correct? If I apply 10 Newton, it may become 11 mm length increase, because on top side I am bounded. So delta R equal 10 ohms. How will you measure this one? For that only we are going to use what you call a Wheatstone. I can use ohm meter. The best thing is using a Wheatstone bridge. This is the Wheatstone bridge. Wheatstone bridge consists of power supply, which is called a bridge supply. You have to supply constant voltage, for example, 5 volts or 10 volts. Okay, that voltage is upright. So Wheatstone bridge consists of 4 arms. This is R. Wheatstone bridge consists of 4 resistors. Each one is called 1 arm. This is second arm. This is third arm. In the fourth arm, correct? All the normal Wheatstone, you have resistors. When R1 equal to, correct, already. Normally in Wheatstone bridge, R1 equal to R2 equal to R3 equal to R4. If it is a resistor, instead of resistor, what I did, I replaced with my strain gauge. Correct? The strain gauge I replaced, which is stuck on my cantilever beam. So that means generally the strain gauge comes in constant fixed resistance. I say RSG. The resistance is 120 ohms. Or 600 ohms or 1200 ohms. These are the values supplied if I buy HBM strain gauges. If I measure the resistance in your ohm meter, it will be 120 ohms, 600, 1200, something like that, the fixed resistance. For example, for understanding purpose, I have bought 120 ohm resistor, correct? The strain gauge SG equal to resistance equal to 120 ohms. Then these 3 resistance should be 120 ohms. These 3 resistors are called a fixed bridge resistance. Fixed bridge resistance. Resistances. Correct? So now there's a power supply. I give 10 volts. Okay. Then my strain gauge is connected. Now, if in a strain gauge, what we are doing is we are supplying a bridge voltage across these two nodes. I mark with red color. These are called where two resistors are connected. I call one node. I call node 1, node 2. Across this, I am supplying a bridge voltage. What? How much? For example, 10 volts. Now, across other two nodes, I mark it in green color. These two are opposite nodes. This node what I call V1. This node I call V2. This is the output of the bridge. V0 equal to V1 minus V2. Okay, which is called difference voltage. Now, if I apply normally, if all this is 120 ohm, this is 120 ohm, the strain gauge also 120 ohm strain gauges when there is no load condition. You have stuck your strain gauges on the cantilever on the top side, correct? But no force, F equal to 0. In that case, the resistance equal to 120 ohms. They are called no load resistance. Then I can find out V0, output voltage here. V0 can be written as V0 equal to, this is called supply voltage, VB multiplied by R2 divided by this resistance divided by R1 plus R2 minus RS, that is strain gauge resistance divided by strain gauge resistance plus this resistance. So this is the formula. Okay. Now we know that this resistance is 120 ohm. This is 120 ohm. This is 120 ohm. The resistance is 120 ohm when there's no load condition. Okay. Now, if you applied 1 Newton force, I told you I apply F equal to 1 Newton. What will happen? The resistance, this strain gauge resistance alone will become 120 ohms, 121 ohm or something. Correct? For example, 121 ohm. Okay. In this formula, what is V0? V0 equal, for example, this is 10 volts. 10 multiplied by 120 divided by 120 plus 120 minus 121 divided by 121 plus 120. When you apply 1 Newton force, N equal to 1 Newton, correct? F equal to 1 Newton. Okay. If F equal to 0, this will be 120, this also 120. So if I give 5 volts, what will happen? V1 will become 2.5 volts. What is what I said? Sorry, 5 volts. 5 volts. V2 also will become 5 volts. What is V0? 5 minus 5 equal to 0 volts. That is when there's no load condition. Now we apply 1 Newton force. So the resistance is 121. So accordingly, if we calculate, V1 will remain as it is, 5 volts. V2 will be greater than 5 volts. 5 plus some delta V. Maybe you can calculate 121 divided by 221 or 241 multiplied by 10 will give some voltage, correct? So for example, understanding purpose, I say 5.1 volts. So what is V0? V0 is nothing but 5 minus 5.1. So it gives minus 0.1 volts. The minus 0.12 volt is proportional to the force applied. Like this, if you apply different forces, you will get different voltage V0. Because this alone is changing, correct? Strain gauge resistance alone is changing. Other three resistance, this how you measure the force applied. So this is called as strain gauge sensor. You can apply force and get it. Any doubt? The
Sir,
formula is for note down.
Sir, can I ask one question? If you know?
This circuit also you have to note down. Exam, you are expected all these things. Okay, yes, please.
Sir, basically this wire is wounded like a serpent, like
yes, to increase length. See, yeah,
so
R is proportional to length and rho and A, correct? If I want more sensitivity, you apply 1 Newton force. If I want more change in delta R, that means original this will be longer. Correct? So that's why they put a serpent. Yes, please. If you are asking something.
Yes, got it, sir. Thank you.
Okay. Now, the strain gauge, if you talk about strain gauges, they say strain gauge can be configured as a quarter bridge, half bridge, full bridge. Because we know that the Wheatstone bridge has 4 arms, correct? In half bridge configuration, the bridge, the arm 1, arm 2, arm 3 are fixed resistance. I told you 120 ohms. Please note that this need not be 120 ohms. For example, this is 600 ohms. because I said 120 ohms strain gauge is there, 600 volt, 1200 ohms resistors are there. So depending upon whatever the strain gauge you are using and no load condition, if it is 120, the bridge in other three should be 120. If it is 600, all these things should be 600 ohms. Then only R1 equal to R2 equal to RS should be equal, correct? So that you have to be careful. If you are using 600 ohm resistor, the fixer is R1, R2, R3 should be 600 ohms. If you are using 1200, it should be there. Okay. Now, if I use one strain gauge and connect it to one arm of the V-stone bridge, it is called a quarter bridge. You know, correct? Quarter means 1/4. Correct? In Roman system, quarter means quad means 4. Quarter means it has 4 arms. Out of the one arm alone is my strain gauge. So that is used bonded on my cantilever. This is my cantilever, correct? And I am applying a force F. I wanted to find what is the force. So what I did, I bonded my strain gauges on the top side, and the R4 resistor is nothing but my strain gauge, which is undergoing under strain. Correct? When I apply a force, that means there's a change in resistance. So now you can find out what is output voltage. Bridge output voltage V0 equal, you can write down this formula in quarter bridge. The output voltage V0 equal to Vs is nothing but the supply voltage, bridge voltage. I said VB or V supply. Some book they write V supply voltage, somebody write V bridge voltage. V bridge multiplied by delta R by R. Correct? Actually, this should be delta S, RS divided by S. Correct? Staying here to understand easy. Okay? Divided by 2 into 2 plus delta RS divided by resistance. This is change in strain gauge resistance divided by original resistance. Original is 120 ohms. Depending upon the force supplied, delta R can be 1 ohm, 2 ohm, 3 ohm. Correct? Multiple this one. This is a formula you have to use. Note down this formula. It is a quarter bridge. Instead of that, for example, when we are applying a force, if I apply 1 Newton force, the output voltage V0 is 0.1 ohms for 1 Newton. F equal to 1 Newton. If I want to now in the this is output because I supplied voltage 10 volts and this is what is giving. Now you apply 0.1 Newton force, 10 times less. What is the output voltage? V0, 10 times less. That means 0.01 volts. Correct? 0.01 volt is very small, 100 millivolt. Correct? It is 10 millivolts. So very small. Correct? That is 10 millivolts. This is 100 millivolts. Okay, that means if I cannot measure small quantity. If I want to measure small quantity of force using the strain gauge, then one thing is I should have a strain gauge whose resistance changes. That strain gauge with a higher gauge factor, it is better. That is nothing but delta R by R divided by delta L by L. Okay, that is called gauge factor. Normal strain gauge, the gauge factor is 2. Most of the they call metallic strain gauges, develop HBM, all those things will be around 2, 2.5 or something that. Okay, generally higher is better, but more that is what it said. Now that my strain gauge factor is fixed, everything is fixed. If I want to increase the sensitivity of measurement, force measurement, which is on cantilever, I can go for what you call off-bridge configuration. Off-bridge configuration nothing but in V-stone bridge, 2 arms, correct? R1 and R3 are against fixed ohms, 120 ohm fixed resistance. Now, I have 2 strain gauges. One strain gauge is bonded on top side, R4, correct? This is my R3, this is my R4. Okay. Now, bottom side also I put one more strain gauges. If you apply a force on the cantilever like this, downward force, what happens? The top side lengthens because of tensile, bottom side a compressive force. So this strain gauge length delta L time reduces. L minus delta L, correct? A equal to A minus A plus delta A. Bottom side area is increasing, correct? Length reducer. Top side L plus delta L, A minus delta A. So top side tensile force, bottom side compressive. So both one resistance will increase, this will increase, bottom side will resistance will decrease. Now these 2 resistors are connected in this arm. Please see that this is very important. You cannot connect this strain gauge here. Correct? You have to connect in specific form only. So one going under stress, correct? That is, this is compressive stress. This is tensile strength. So,
Right.
yes, please.
Sir, another 5 minutes is there, sir.
1 minute. I will complete in 1 minute.
Right,
I know
sir.
that you have to go
Thank
for
you, sir.
next class. So this is
Yes.
called a half bridge. Now the output sensitivity of this same amount of force, the amount of voltage V naught will be double. Note down this formula. Correct? Formula is Vs is the supply bridge voltage multiplied by delta R by R divided by 2 plus delta R by R. You can see this formula here or this one. Instead of that, if still I want to more output for same amount of force, I can go for full bridge. Full bridge means all the 4 arms are strain gauges. Only thing is strain gauge should be bonded in this fashion. So R4 is put like this, transverse condition, correct? And similar R3 in the bottom side, transverse condition with respect to cantilever. And the R1, R2 are put like this, right? And these 4 strain gauges should be connected in the bridge in this fashion. You see that this is going in the tensile, this is tensile, this is compressive, this is compressive. Then the output V naught, you can take this formula alone. V naught will be Vs into delta R by. You can see that the output voltage for given amount of force, same amount of force will be 4 times. This will be 4 times more than the quarter bridge. This will be 2 times more than quarter. This is just as it V naught, right? 1 type. That is called quarter bridge. So this is called a quarter bridge, full bridge, half bridge, any bridge you can use. I stop here, and we will next class we'll go to other sensors. Thank you very much. See you tomorrow evening 5 o'clock.
Just a question.
Yes,
Here.
please. Yeah.
Previous slide. So the top one quarter bridge is the same as the previous one, like in the previous slide, right? Correct?
Yeah.
Correct.
Here.
Yeah, that's the same one. Yeah. That's okay. Okay. And another question is on the can you please go to the next slide, sir? Yeah, the below one quarter bridge is strain circuit with the temperature compensation.
Yeah, nice thing. Somebody asked, for example, if I fix my strain gauge, temperature changes, won't it resistance changes? Correct? I told you they use a special material which resistance will not change. Originally, only for strain applies force. Correct? This part, and derivation also. This is the main contributor. Correct? Piezo-resistive effect, main contributor, which is directly proportional to strain applied. Correct? Other thing, due to temperature, resistance can change. We know that resistance can change. First sensor RTD. Yes. Similarly, the strain gauge also can change. That's why they select a special material. In spite of that, if temperature change is too much, correct? And then there will be change in resistance. How will you compare? For that, what you do is, this is the actual strain which is going under the put on the cantilever. This one, and instead of having this fixed resistance, they take same strain gauge, same value from same make and connect it as a fixed resistance. This will be 120 ohm because there is no force applied. Correct? This is 120 ohms. This is also 120 ohms. This resistance will change 120 plus or minus delta R. This is which bonded. So any change due to temperature effect, that is automatically compensated by this. That's why they call temperature compensated Wheatstone bridge.
Okay, but will it be placed on the parts?
No. If you put it on a part, then it will go under stress, no?
Stress. Okay, yeah.
It will be floating. It will be just not connected on any road. It is without any force. It will be part of the bridge circuit.
Okay, sure, sir, sure.
So they call temperature compensation. As somebody asked, if the lot of change is there, no other option, you have to go for temperature compensation like this. That means same make, same brand and same thing. You will take 2 strain gauges from same thing. One will be bonded on the material where you want to measure. Other will be just connected as the bridge, just like other 2 resistors. So it forms. But these 2, please note the another thing. R1, R2, R3 have a resistance 120 ohm. And it will not change the resistance, even temperature change, even 20-degree change, 30-degree change. Very special resistors. They are called fixed resistors. They also should not vary. Okay. If they vary, there will be a drift, will be thermal drift will be there. But there are special available. The whole thing is available. The whole thing is put inside a circuit available as amplifier, strain gauge amplifier. This HBM is selling that. When you buy strain gauge, you need to buy strain gauge amplifier also. Otherwise, you can build. Correct? Strain gauge amplifier needs not only the output, there will be an additional circuit needed. That is a big task. That should be temperature compensated many times. Better buy the strain gauge amplifier from the same manufacturer. Generally, they will be selling strain gauge plus amplifier. Buy it from them. That's better. I stop here. We can see tomorrow.
Okay, sir. Thank you. Thank you, sir.
Okay. So we'll go to next sensor. Already we saw 3 important. Next sensor we'll see tomorrow.
Thank you, sir.
Give your attendance before leaving as a chat message.
Thank you.
Okay.
Production plant, he will witness the process.